Okay, hi everybody. Hopefully you did all of this with the sub. Remember that if K is more than 1, then the products are favored. And if K is less than 1, then reactants are favored. Okay, make sure you finish all of this either by looking at the notes or writing them from the paper. Okay, and now I'm gonna go over example number 2, and then you can do example number 1 by yourselves. It says a container has the following at equilibrium: 0.100 molar H2, 0.0600 molar N2, and 0.0800 molar NH3. What is the equilibrium expression? We're gonna do exactly what we've been doing. KEQ equals, okay, remember to divide. These are the reactants, these are the products. Okay, always remember that KEQ is products divided by reactants, and scan for solids or liquids. I have none, so we are good to go. Okay, so the products are on the top, so that is going to be NH3 to the power of 2. And I have H2 to the power of 3 and times N2 power of 1. I don't need to write that down, so I'm just going to go ahead and erase it so I don't get confused, because it is just it's just a power of 1. Okay, so now instead of writing these ones, I'm gonna write down the actual numbers. Notice I have the actual numbers for each one. So KEQ is going to be 0.0800. Don't forget the exponent, okay? So this exponent right here must be right here. Remember how we used to do it with the pH with the caret? Okay. H2 is 0.100. Don't forget to put the exponent times 0.0600. Make sure you multiply the top and then you multiply the bottom. Okay, put this in your calculator. I believe the bottom is 0.0006 and the top is 0.0064. And if we divide them, we get KEQ equals 106.666, and go on and on and on. We have 3 significant figures right here, 3 significant figures. So we're going to do 1, 2, 3. And that is KEQ is the same as 107, no units. And is favors or reactants products. This is more than 1. This is more than 1. So products are favored. Okay, go ahead and try example number 2 by yourself. And at the end, Mrs. Escalante is going to show you the answer.
What I want you to do is to circle the chemicals. Okay, so we only have 2 chemicals. I want you to underline the coefficients. If there's no coefficient, go ahead and write the invisible one that should be there. Okay, finally, go ahead and put the arrow with your third color. And you can even go ahead and divide this between the reactants and products. Okay, so I'm going to write my KEQ equals. Remember that my arrow marks the separation. So I'm going to make my line the same color as my arrow. And remember that KEQ is the same as products over reactants. So I'm going to write my products first. So the concentration of N2O4 to the power of 1. So we usually don't write the power of 1, so it's totally fine if you don't write it down, just for powers of 1. And then reactants on the bottom, the concentration of NO2 to the power of 2. Okay, so let's go ahead and do 3. Let's go ahead and color code it. All of the formulas, color them with the same color. Now, underline the coefficients. If there's no coefficient, can you go ahead and write down the invisible one? And go ahead and highlight your arrow because this is, again, the division between the reactants and products. As a reminder, KEQ is the same as products divided by reactants. So let's go ahead and write KEQ. I'm going to write down my line the same color as my arrows because this is my division right here. And let's go ahead and write my products. Oh, let me just triple check that I don't have any solids. Nope, no solids, so we're good. Okay, so the concentration of HI to the power of 2. So this 2 is now right here. Let me make it smaller. Right there. Okay, and then on the bottom, we're going to write the reactants, the concentration of H2 to the power of 1. It's okay. We don't have to write powers of 1. And the concentration of iodine to the power of 1 again. So that is totally fine. Okay, I'm going to do one more with you because the following one has a solid on it. And I want to make sure that you know how to do that one. So let's go ahead and color code. Oh, wait. This is a solid. So what I want you to do right away is to go ahead and cross it out and put a 1 for it. Okay, solids and liquids are not included. Okay, now this is aqueous, so this is good. And this is SO4 2 minus, and it is aqueous again. Remember that KEQ is equal to products divided by reactants. Now I'm going to underline my coefficients. Make sure that you put the 1s just so you don't get confused as the coefficients. Make your arrows on a different color. And now let's go ahead and write down our equilibrium expression. I'm going to make my line the same color as my arrow. And I'm going to write my products. Let me make my division right here. My products on the top. So it is the concentration of Ca2 plus to the power of 1. Again, you don't have to write it, but for this one time, I'm going to write it. Okay, times the concentration of SO4 2 minus to the power of 1. It's totally fine if you don't write it. Divided by my reactant is just a 1. Okay, so if you want, you can just write this one. So this is the same as just writing the concentration of calcium times the concentration of SO4 2 minus. And this will be our final KEQ. KEQ equals. Okay, this is it. Make sure you finish the rest by yourself. Good.
I'm going to pick it up on page 96. We're going to just recap on decreasing reactants. So let's go ahead and write down really tiny reactants on the bottom and then normal products on the top. So it means that in order to go back to equilibrium, the products need to decrease, right? And the reactants need to increase. And in order to figure out the overall shift, is always going to be the one that is increasing. So we're gonna write down shifts always to whichever is increasing. So in this case is the reactants. Okay, so let's go ahead and decreasing O2. Okay, O2 is in the reactants. We are decreasing. So let's go ahead and make that R like really tiny and small. Okay, and let's go ahead and make P normal. So in order to go back to equilibrium, we're going to have to, the reactants need to increase, right? The R needs to increase. And the products are going to have to decrease. Okay, so the overall shift is going to shift to, which one is increasing, the reactants or the products? The reactants, shifts to reactants. Okay, so this is when you're talking about concentration. When you're talking about concentration and you have a solid and a liquid, let's see, this looks like S and L. They're going to have no change in the equilibrium. Why? Because the concentrations don't change. Okay? So NaCl, let's go ahead and divide this between reactants and products. NaCl is a solid right here, so this one is going to be no effect or no change. Okay, go ahead and do the next one by yourselves. After I'm done with the video, I just want to make sure I go over everything. I'm going to do a corrections. You already have it corrected in your paper, so don't worry about this one. So this one is exothermic, and this one is endothermic. Okay, so changes in temperature. Make sure we're going to fill this one out. So heat acts like a reactant or a product. Very important. You're going to treat it just like another reactant or product. If it's endothermic, heat is going to be in the reactants. And if it's exothermic, heat is going to be in the products. Okay, so if this is exothermic, heat, and let's go ahead and write down over here, heat is a product because this is exothermic. Exothermic means that it's going to be in the product. Okay, so exothermic, we're adding heat, so the product is going to be big, right? Because products are big because you're adding heat. Reactants are normal. So what is going to happen? We have to decrease the products and increase the reactants in order to go back to equilibrium. Okay, remove heat. We're still in exothermic, so this is products, right? So we're going to remove. So let's go ahead and write products really tiny and then reactants normal. So now products need to increase, right? And reactants need to decrease. Okay, I'm going to do this example and then I'm going to let you do these other ones. 2SO2 is add heat. So notice heat, let's go ahead and do reactants and products. You're adding heat. Heat is where? Heat is in the product. So now we're going to have big products, normal reactants. So this means that the reactants need to increase, right, in order to go back to equilibrium. And the products need to decrease. You shift to whichever is increasing, always, always. So it shifts to reactants. Okay, I'm going to remove the heat now. Okay, so I'm removing the heat. So heat is in the product. So my products are going to be tiny and small. My reactants are going to be big, right? Okay, so sorry, tiny and small. Reactants are normal. This is a really bad drawing. Let me do it again. So removing heat from the product. So products are small and reactants are normal. So it means that reactants need to decrease and products need to increase in order to go back to equilibrium. So remember, it always shifts to whichever is increasing. So this one is going to shift to products. Okay, so now for endothermic, this is going to be, endothermic means reactants. It is, the heat is in the reactants. So go ahead and add heat to the reactants. How would it look like? And go ahead and do these other problems, okay? And finally, when you add a catalyst, it has no effect. It just goes faster, but it's going to have no effect because catalyst only lowers the activation energy. Okay, because catalyst lowers activation energy. It will never, never, ever have no effect on the equilibrium. Okay, so go ahead and finish up these notes. The sub is gonna show you the slides, or it's gonna write them with you guys, and then you can go ahead and get started with the last part of the homework. Okay, bye. Hi everybody, this is the last little section of today and it's just finishing up the notes. I'm just going to do this one a little bit with you. So remember to always divide it, right, between the reactants and the products. And our first one is to add N2. Okay, so N2 is in the reactants. So it means that the reactants are going to be really big and the products are going to be normal. So it means that products need to increase, right? And then reactants need to decrease. Okay, so it's going to shift to the one that is going up, which is the products. N2 has no change. H2 is in the reactants. The reactants are decreasing. NH3 is in the products. So you are increasing, right? The products are increasing. Okay, I'm going to do one more with you. Remove H2. Let me change the color. H2, let's look for H2. H2 again is in the reactants, okay? So I am going to remove H2. So the reactants now are going to be really tiny. Products are normal. So it means that now products need to decrease in order to go back to equilibrium and reactants need to increase in order to go back to equilibrium. So it's going to shift towards, let me move this. This is not a good place. Let's go ahead and put it right here. This is going to shift towards the reactants. Okay, N2 is in the reactants. Reactants are increasing or increases. And then NH3 is in the products. Products are decreasing. Okay, so good luck everybody. And this homework is due on Friday. Bye.